This is N. Kalvili, working as an associate professor in KS Rangasamy College of Technology. Today's topic from electrical energy utilization, conservation, and auditing subject. Third module, electrical energy in electrical efficiency in electrical utilities, compressor. A compressor, it is a device which takes a definite quantity of fluid or air and deliver it as a required pressure. And as a air compressor, it takes from the atmosphere, and it will compress and it will be delivers to the storage vessels as in reservoirs. So the work to be done in the gas or liquid, the compressor must be driven by some sort of prime movers, just like engine. And how it is different from pumps. So major difference in the compressor handles the gases, but the pumps handles with the liquid as like a fluids. As the gases are compressible, and the compressor also reduces the volume of gas, and liquids are relatively incompressible. So while some can be compressed, some of the oils or liquids can be compressed, and mostly the liquids are not incompressible, but the gases are compressible. The gases are compressed by compressors, and the pumps will be pumping the fluids. So that is the difference between the compressor and the pumps. And as we come to the applications of compressor, and compressors may have in everydays, such as air conditioning system, pneumatic devices, home and industrial refrigeration, hydraulic compressors for industrial machines, and air compressor for the industrial manufacturing. Whenever we are coming to the classification of compressors, it can be classified in the following manner. So the compressor can be divided into positive displacement and dynamic. So the positive displacement compressors are finally divided into rotary and reciprocating. The dynamic is divided into centrifugal and axial. So we will see one by one in the next four coming slides. The first one is about dynamic compressors. So the what is the dynamic compressor? It is a continuous flow compressor, and it is characterized by rotating impeller to add velocity and this pressure to fluid. So it is widely used in chemical, petroleum refinery industry for specific services. There are two types. The dynamic compressors are two types. One is centrifugal and axial flow compressors. In this centrifugal compressor, it is achieved the compression by applying inertial forces to the gases by means of rotating impellers. And it is a multiple stages, so we can have a single stage, multiple stage, as well as single cylinder and multi-cylinder. And this is comes under multiple stage, and each stage consists of an impeller as the rotating element and the stationary element. One is a rotating element and another one is a stationary element. For example, that is diffuser. So fluid flow enters the impeller axially and discharges radially. The gas next flows through a circular chamber diffuser where it loses velocity and increases pressure. So it can be the velocity is reduced and the pressure will be increased. So this is a schematic diagram of a centrifugal compressor. Next one is axial flow compressor. So working with the fluid principally flows parallel to the axis of rotation. The energy level of air or gas flowing through it is increased by the action of the rotor blades, which extract the torque on the fluid. This real picture is given in the diagram, axial flow compressor, and it is also having a benefits of high efficiency and large mass flow rate, and also requires several rows of airfoils to achieve large pressure rises and making them complex and expensive. Another one type of compressor is about positive displacement compressor. The positive displacement compressor, it causes a movement of trapping a fixed amount of air, then forcing that trapped volume into the discharge pipe. And it can be further classified into rotary compressor and reciprocating compressor. And this is a positive displacement compressor with a rotary and reciprocating. So this rotary is comes under the centrifugal type, and the reciprocating is also divided into two types: a number of stages and number of pistons operation. The number of stages is single and multiple, and this is a rotary compressor. The gas is compressed by the rotating action of a roller inside the cylinder. So here the roller, exhaust port, and impeller and intake port, everything is given in the picture. Stage by stage it is explained. So the refrigerating vapor and intake port, so it is compressed and it will be taken into it will be compressed and it will be taken out. So if we have intake port and exhaust port, so in the intake port the air will be taken into that and it will be compressed, and finally it is to the exhaust. So the roller rotate of a center around the shaft so that the part of the roller is always in contact with the cylinder. So the volume of the gas occupied in reduced occupies is reduced and the refrigeration is compressed. So as a reciprocating compressor, it is a positive displacement compressor, and that uses pistons driven by crankshaft to deliver the gases with a high pressure. So in the first figure, it shows the air will be taken. The valve inlet intake valve is open and exhaust valve is closed. So whenever the piston is downwards, it will take the atmospheric air from the intake valve, and once the intake valve is closed, it will be the piston will be in a upward direction. So that will be showed in second figure. So air will be compressed and it will be given to the it will be exhaust to the exhaust valve. So this is the principal operation of an rotating reciprocating compressor. According to this principle, once the piston is downward, atmospheric air is taken into the piston in the cylinder. So once the cylinder is downward to it will be coming from downward to upward, the intake valve is closed and the exhaust valve is open. Both valves are closed and the air will be compressed. So finally, the compressed air will be exhaust from the exhaust valve. So this reciprocating compressor usually has two, three, or four cylinders, or number of cylinders also. So this is a stage by stage cylinder, how the piston is moving downward and upward, how the valve, suction valve and discharge valve is opening and closing. That will be given in different pictures. So the first, the piston is downward, it is suction to stroke. Once the piston is downward to upward, it is compression stroke. So why we need a multiple stage of compressor? So with a high temperature rise lead to limitations for the maximum achievable pressure rise. So the discharge temperature shall not be exceed 150 degrees C Celsius and should not exceed 135 degrees Celsius for the hydrogen rich services. So multi-stage compressor compresses air to the required pressure for the multiple stages. So intercoolers are used between each stages, and it removes the heat and it decreases the temperature. So that we are using multiple stage compressors. So here the reciprocating compressors with multiple stages. Finally, we have to come across with a low pressure, intermediate pressure, high pressure are given by LP cylinder, IP cylinder and HP cylinder. So initially we are go with low pressure. So series arrangement of cylinders in which compressed air from a earlier cylinder. The first stage will be low pressure cylinder, and intercooler is connecting low pressure cylinder to the intermediate cylinder. Another one intercooler is connecting intermediate pressure cylinder to high pressure. So the air is taken from the taken to the low pressure cylinder and air delivered at high pressured cylinder. So the intercooler is used for the compression of air is cooled between the cylinders. And we finally come into the advantages and disadvantages of dynamic compressors. So there are dynamic compressors are centrifugal and axial, and centrifugal compressors are wide operating range, high reliability and low maintenance. And the major disadvantages: instability to reduce at reduced flow and sensitive to the gas composition change. For an axial cylinder, high capacity for given size, high efficiency, heavy duty and low maintenance, these are the advantages. And the low compression ratios, and it have a limiter turn down. Another one, positive displacement compressors having a advantages and disadvantages. Here we have a reciprocating and diaphragm. So the reciprocating is advantages for wide pressure ratios and high efficiency. The disadvantages: heavy foundation required, low pulsation and high maintenance. For the diaphragm, it's a very high pressure, low flow and no moving seal. And the disadvantages: limited capacity range, periodic replacement of diaphragm. And the screw type of displacement compressor, it's wide application, high efficiency and low cost. And it is expensive and unsuitable for corrosive or dirty. So up to this we can come across with the compressors. I can meet you in the next video. Thank you.